This is the basic setup for the force on a ramp activity. The purpose of this lab is to investigate and find equations for two forces that are acted in conjunction. One force is the horizontal force going up and down a ramp. If you have an object, if we ignore friction, if we have an object on a ramp, there's a force pulling it down the ramp, but there's also the force of the board pulling up. In physics, we always call the force perpendicular to the surface the normal force. So we have a normal force pushing up on the board, from the board on this object, and we have a force of gravity pulling it down the board. And we're going to measure that force with this force probe. We're going to measure the horizontal force with the force probe, and we're going to measure the normal force with our scale here. So your first step in your lab will be to actually have this board flat, and you'll need to weigh this fan cart. Now when you set the fan cart up, you want to make sure the wheels are on the scale and it's not off to the side. And when we elevate the board, that's another thing you'll need to check. This fan cart, this is supposed to be frictionless. Okay, so there needs to be that if you let go, cut the string, it would roll right off the scale. So the first thing you do is you weigh the fan cart with the board flat. You can check the angle. You probably should check to make sure you know how to use your iPads to measure the angle, and your angle should be basically 0 when it's flat on the floor, and you should 0 the force probe while it's connected to the pole. Then the next thing you do, obviously the force in the beginning for the horizontal force will be 0. The next thing you do, you'll raise this up to a 10-degree angle. Now this picture is bigger than a 10-degree angle. Then once you do that, somebody will need to read this scale, and you should set it to where it's reading in newtons. That'll make your life simpler. So we're going to measure the force, normal force going up, and we'll measure this force of the force probe. Now this is fairly sensitive. This is a fairly sensitive lab, so we want to make sure this string is parallel to the board. And one reason I used a longer string, I even measured the height here and the height here to make sure it was parallel. Because if you're pulling up or down on the string, then your results aren't going to be very good. Then you're going to record this information in the data, in the table, which I'll show you. You can look in you've got a picture of the notebook, but you have a table in your notebook. You record the data, and then you'll go to 20 degrees, 30 degrees, 40 degrees. Now as this gets higher, you can see I have a string here because it was just me securing this the stand. Okay, probably work best to have somebody hold the stand. As this board gets higher, you need to make sure it stays secure, and the stand will slide if you don't hold it. And you may, at 60 degrees, I didn't go that high, you may have to have somebody don't hold the fan cart, but hold the scale so it doesn't slide down the board. 60 degrees is a fairly steep angle, but you can prop up the edge of the board, you can slide it up on one of the tables, you can use your imagination to figure that out. And that's really all the data that we have to collect, and then you can follow the instructions and look at the lab notebook information, which I'll show you at the last part of this video to figure out the rest of the lab. Good luck. At this time I want to go over how I want your lab notebook to look like. As always, we want the title, Force on a Ramp Activity. I would like this diagram here, and again you have the picture on the website if you need more time than what this video has. This represents what we're measuring. I have the force horizontal going down, or in the lab our probe is pulling up, but those forces are matched up, so what we're actually measuring is the horizontal force down the ramp. So you have a table with your angle that goes 0, 10, 20, 30, 40, 50, 60. I only put data in for 40 degrees. You'll see in a minute why I did that. That of course is just made up data. And you have your FH, which is your horizontal force down the ramp, and your F normal. Normal is perpendicular in physics and math. So the normal force is the force that's perpendicular to the ramp. You need to have generated equations. Once you get this data, the instructions tell you to generate equations using the sine regressive function in your graphing calculator. I didn't write down what they were because I don't have real data. Then I'm supposed to make a vector diagram. Using my fake numbers, you only do the vector diagram for the 40-degree angle. So it's going to look something like this, because these should make a right angle right here. And in my example, my resultant force was 99 newtons, which was much bigger than any forces we're going to have. And you're asked, what does F of R represent? You should write that down. As always, I can always give you some help, but I'd like you to think about it, see if you can figure it out on your own and do a little discovery learning about how all this stuff works. Then the last thing you need to do is we have our theoretical equations. As always, when you do lab data, it doesn't quite match theory. So let's think about it. I can give you some guidance if you need to, but maybe even ask somebody else that's the other lab groups that are working on this same lab, and see if you guys can figure out what the theoretical equation should be, and then we'll do a percentage difference. I use 63 and 77. I don't know what this number is because I didn't write down the equations. So that's how you would do the percentage differences. So there's not a lot of data to collect, not a lot of work that you have to do with the data once you collect it in this lab. Good luck.